This research is LMI optimization-based multirate steady-state Kalman filter design. Periodic gain is designed based on LMIs. There are many sensors in the complex systems, and it is required to fusion sensors in multirate sensing environment. Prompt is given by this state space model, and the matrix S characterizes the sensing timing. The objective is to design periodic steady-state Kalman gains in multirate sensing environment. In case of standard Kalman filter, the solution can be obtained by solving Riccati equation, which include positive definite covariance matrix. For multirate case, it is difficult to solve Kalman filter in multirate setting. To overcome this difficulty, we apply cyclic reformulation for multirate systems. Equivalent time invariant system is obtained. By applying Riccati equation for this system, then the covariance matrix is positive semi-definite. In such case, Riccati equation is unsolvable because of the positive semi-definite covariance matrix. Therefore, in this case, LMI optimization-based method is useful for design periodic Kalman gain. In numerical simulation, the number of states is 3 and there has 2 sensors. One is GPS sensor and it is 10 periodic. Another is wheel speed sensor and it is sensed in all time. Left figures are true and estimated value of each state, position, velocity, and acceleration. Right is the estimation error. We can see Kalman gains work well. Various sensing periods are compared in this slide. Optimal estimation error covariance are shown for each sensing period.